Today is day 1 of proving triangles congruent. Now let's remember, when we have congruent triangles, we have 3 sides from one triangle are congruent to each of the 3 sides of another triangle, and same thing with the angles. So that we have 3 different pairs of angles that are congruent, and we have 3 different pairs of sides that are congruent. Now, in order to prove that triangles are congruent, we actually don't have to prove that all 6 of those pairs match up, meaning 3 pairs of angles and 3 pairs of sides. What we're going to look at today are different ways that we can prove triangles are congruent. The first way is ASA Postulate, which stands for side, side, side postulate. So what that means is, if I have 3 sides from one triangle are congruent to 3 sides of another triangle, then I can say that the triangles are congruent. So in our example here, we have one that has a measurement of 4 centimeters. AB matches up with segment DF, as you can see in red. And then we also have in green that we have one side is 7 centimeters and another side is 7 centimeters. And the last pair has a measurement of 6 centimeters. So because we have 3 sides that match up with 3 sides of the other triangle, we can conclude that these triangles are congruent. Our second method is called SAS Postulate, which stands for side, angle, side postulate. So what that says is, if I have 2 sides of one triangle that are congruent to 2 sides of another triangle, and an included angle, that's really the biggest thing, and we'll come back to that, and an included angle that is also congruent to an included angle from the other triangle, we can conclude that the triangles are congruent. Now, what does that word included mean? It means in between, inside. So for instance, we have segment AC is congruent to segment DE. We also have segment AB is congruent to segment EF. So what we need now is we need our included angle, which in this case is angle A. That's the one in between those 2 sides. And in the triangle DEF, angle E is in between those 2 sides. So they're considered included angles. So therefore I can say side, angle, side. And in my other triangle I can say side, angle, side. So since I have 2 sides and included angle from one triangle that is congruent to 2 sides and an included angle from another triangle, I can conclude that the triangles are congruent. Our next postulate is called angle side angle, ASA. So similar to what we did in the last example, I need 2 angles from one triangle if they're congruent to 2 angles of another triangle, and the included sides are also congruent, then I can say that the triangles are congruent. So again, I have 2 angles. So in this case I have A, angle A is congruent to angle D, and I have angle C is congruent to angle F, and the side that's in between, that's my included side, they're also congruent, so therefore I can say these triangles are congruent by angle side angle. Next I have angle angle side theorem. So again, if I have 2 angles from one triangle that are congruent to 2 angles of another triangle, and I have one side, but this time this one side has to be non-included. So we'll take a look at what that means. So in this case I have angle G is congruent to angle K, and I have angle J is congruent to angle M. Now in between those angles are considered included sides, but in this case we don't want that. We're going to take those away. That's not what we're looking for. An angle, angle, side, we're looking for a side that is not in between, not included. So in this case, that side is going to be ML and also segment HJ. So because I have 2 angles from one triangle that are congruent to 2 angles of another triangle, and I have one non-included side from each triangle that are congruent, I can say that these triangles are congruent by angle angle side theorem. We have one more theorem for today called HL theorem. Now up to this point, everything we've used to show congruency has 3 different things, 3 combinations of sides and angles. As long as you can show those 3 parts are congruent in the correct order, you have congruent triangles. Now HL theorem is slightly different. We still need 3 things to prove that the triangles are congruent, but you'll see that they're slightly different than the ones we've done before. One thing I need is a right angle. I need a right angle in each triangle. I also need the hypotenuse of each triangle has to be congruent, and one of the legs has to be congruent. So if I have those three things, one right angle, the hypotenuse is congruent, and one of the legs is congruent, then I can say the triangles are congruent by HL theorem. So if we look at our example, angle B and angle E are not only congruent, they're right angles. My hypotenuse, remember, the hypotenuse is the segment across from the right angle. So in this case, it's segment AC. And in my other triangle, the hypotenuse is segment DF. Now I'm looking at for legs that are congruent. So I have segment BC is congruent to segment FE. So therefore I have my three pieces, so I know that this triangle is congruent because of HL theorem. The H stands for hypotenuse, the L stands for leg, and a right triangle is the only type of triangle that will have a hypotenuse, so that I know I also need a right angle to prove that the triangle is a right triangle. Let's look at some examples and see if we can identify whether the triangles are congruent, and if they are, by which method. So number one, I have a pair of sides that are marked as congruent, and I also have a right angle that are also paired as being congruent. Now in this case, this segment BC is a reflexive piece. The segment BC is part of both triangles. So in this case, I have a side that's congruent. I have an angle that's congruent also in both triangles. In this case, they happen to be 90 degrees, but that would mean that they're congruent. And I also have another side. So it looks like these triangles are congruent by side, angle, side. So let's write a congruency statement. When writing a congruency statement, it's a good idea just to write the first triangle in any order you want and then just match up the corresponding parts. So I have triangle ABC, and that matches up with triangle SBC. Angle A matches up with angle S. In this case, angle B matches up with angle B, and angle C also matches up with angle C. So there's my congruency statement. Now number two, I have sides that are already matched up as being congruent, and I have an angle, again, that's also matched up as being congruent. It's a right angle. And then I also have angle NCM is congruent to angle ACB because they are vertical angles, and we know that vertical angles are congruent. So again, there's my angle, there's my angle. So what I have here is I have angle, angle, side. So again, for our congruency statement, I have triangle NMC. I'm just going to write the first one in any order. And angle N matches up with angle B. And then angle M matches up with angle A. They're both at 90-degree angles. And then my last angle is angle C. So there's my congruency statement. Triangle NMC is congruent to triangle BAC. And looking at number three, I have some angles that are already marked. And I know that the sum of the interior angles of a triangle is 180. So if I do my math, I realize that this missing angle here is going to be 59 degrees, and this missing angle over here is 61 degrees. Now, the other thing I know, so I have three angles. There is no such thing as angle, 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 postular theorem, so that's not enough. So I need to see if I have a side that is congruent. Now, none of the sides are marked as congruent, so I need to see what I have. This piece AC right here, that's a reflexive piece. So if I look what I have 61 matches up with 61 here, and 59 matches up with 59 there. So I have an angle, a side, and an angle. So I can actually say this is angle, side, angle. I could also say actually that I know in addition that that third angle is also congruent. 60 is congruent to 60. So I could also say that I have angle, angle, side. So either one is okay. Angle, angle, side, or angle, side, angle. Now let's do a congruency statement. So again, our first triangle, let's write that just any order. So I have GCA is congruent to triangle. Now I need to match up my angles. Angle G is 60 degrees, so that's going to match up with B. Angle C is 61 degrees, so that's going to match up actually with itself there, angle C on the other side. and angle A is 59 degrees, same thing, that matches up with angle A on the other triangle. So my congruency statement is triangle GCA is congruent to triangle BCA. And looking at number 4, I notice that I have segment AC is a reflexive piece. That AC is part of both triangles, so I'm going to mark that. I don't know if I need it, but I'll mark it. Now I have two sets of parallel lines. So if I extend these lines, then I have a transversal. There's my transversal here. So I can say that angle ACD is congruent to angle BAC because they are alternate interior angles. Now I can do the same thing. I have another set of parallel lines. So let's use I have BC and AD are also parallel. And I'll use the same transversal. So when I do that, I notice I also have another set of alternate interior angles. So angle BCA is congruent to angle DAC. So now I notice I have two angles from one triangle are congruent to two angles of another triangle and the included side. So I have angle, side, angle. So let's do my congruency statement. So I have triangle ABC is congruent. So A right here is my red loop right there, my red arch. That matches up over here with C, so that's triangle C. And then my B, angle B matches up with angle D, and angle C on one triangle matches up actually with angle A on the other triangle. So my congruency statement is triangle ABC is congruent to triangle CDA. In number 5, I have two triangles that are right across from each other, and they form some vertical angles, so that's going to be congruent. I also notice that I have parallel lines, so I'm going to extend those just a little bit so that I can see them a little easier. And there's one transversal. And when I draw that one transversal, I notice that this angle is congruent to that angle there. So angle ACB is congruent to angle BYU because the alternate interior angles are congruent. I can draw another transversal, segment AU. And when I draw that, I have another pair of alternate interior angles. So angle CAB is congruent to angle BUY. So I have three congruent angles in each triangle, but unfortunately for us, that doesn't prove congruency. There is no postulate or theorem that says angle, 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 so we're going to say that this is no congruency. And looking at our last example, number 6, I notice I have vertical angles. So I have two sides and an angle, but unfortunately, I need that angle to be in between the side. It has to be included. In this case, it is not. I have a side and an angle. But unfortunately, again, for us, that doesn't prove congruency. There is no postulate or theorem called SSA, so again, this one is not congruent. So no congruency can be proved.